Hello everyone. In this video, we continue with functions in R programming language. Last time, we focused on loops in R. We learned how to construct for, while, and repeat loops. You can check that video using the link on the right corner. Let us move on to today's topic. We will focus on functions and answer the following questions. What are functions? How they are used? And second, how can one create a function in R? And then we will focus on how to arrange arguments of a function, and last we will see how to test a function. Functions execute a block of code by calling a single command. They allow you to automate common tasks in a more powerful and general way than copy and pasting. They can also take some arguments and do the operations, which increases their usability. We also would like to give you some of the best practices regarding the functions. First, they need to be short and interpretable. Second, they need to perform a single operation and it should not be that complicated. And lastly, they should have self-explanatory names so that anyone can use them by just looking at their names. Let us start with the syntax. First, we need to write the name of the function. And then we use the reserve word function, and it is followed by the arguments. Note that the arguments are also called as inputs of the functions. After that, by using curly braces, we write down the statements or block of codes that will be executed whenever the function is called. Let's have a look at the example below. Suppose that we want to convert centimeters into meters. We can easily do this operation by just dividing the number by 100. However, we can also write a function for this operation. Our function has a name, centimeter to meter, and it takes an input called cm. Then we calculate the meter as m and return the value of m. Let us have a test on the function by just writing its names. Suppose that we have 100 centimeters. When we calculate the meter by using the function, and it will result 1. This applies for 350 centimeters, and the function results 3.5 meters. As I said in the beginning, functions should perform a single operation, which means we sometimes need to combine these functions. We will see an example of this. Suppose that we want to convert millimeters to meters by using centimeter to meter function. First, we need to write a function that converts millimeters to centimeters. It is almost the same as centimeter to meter function. However, this time it needs to divide the input by 10. After inspecting the function with 150 and 4350, we can continue with combining both of them in another function. Now we will have a function called millimeter to meter, and it takes a single argument mm. It will first convert mm to cm and then cm to m by using millimeters to centimeters and centimeter to meter functions respectively. Let us test the millimeter to meter function with 15,000, which results 15 meters. And also we can see the same stuff for 4200s, which will result 4.2 meters. Alternatively, we can also combine the functions in a different way. This time, we use the functions we created before. We first use millimeter to centimeter with an input of 15,000, which results 1500, and then use this output as an input to the centimeter to meter function. And in the end, we will have again 15 meters. This also worked for us. However, it is important that we should not nest too many functions, as it is not easy to read. Lastly, we will focus on the arguments in a function. Arguments allow us to enhance the usability of a function. We can automate an operation that requires different arguments with using a function. Let us have a look at the example. Suppose that we want to calculate a polynomial in the form of a times x plus c. For this, we need to write a function where it takes a, x, and c as inputs. It will perform the calculation and return its value. We can use that function as polynomial 1 to 3, and it will return 5. When we are calling the function, we can also use the names of the arguments. We can also write polynomial a equal to 1, x equal to 2, and c equal to 3, which also returns 5 again. Note that if we use the names of the arguments, this also allows us to deviate from the ordering. What I mean by this, as in the example, we can also give first x, then c as 3, and last a as 1. So this does not affect the result of the function, which is 5. Lastly, we may want to determine default values for the arguments. This can be useful if we are calling a function with some default values. Suppose that our default values for the polynomial function are a equal to 1, x equal to 3, and c equal to 3. If we are going to use the default values, then there is no need for providing inputs for the function. We can just call polynomial without any input, and it will return 5 again. This is the case since we use the default values. It is also possible to override these default values by using different values. Suppose that our a is equal to 2, x equal to 3, and c equal to 1. This time, we need to specify their values as inputs. And it will return 7 since this time they have different values than their default values. Thank you for watching our videos. Please give us a thumbs up if you like our video. We will continue to create contents with your great support. If you have any questions, please leave a comment below. We will be happy to answer your questions. Bye bye.